The next question here, 4.5.15 in the old book, two bodies of mass 10 and 20 kg respectively kept on a smooth horizontal surface or tied to the ends of a light string, or a horizontal force 600 Newton is applied to A and B along the direction of the string. What is the tension in the string in each case? Okay, 10 and 20 kg. So tension in the string. Now suppose 10 and 20. So 5.15. Now suppose there are two bodies. This is a string and tension T is the tension. A and B respectively. 600 Newton force is applied here. And this is the direction of the acceleration. One is 10 and 20 kg. This is 10 kg, 20 kg. Now, we will take this as, because we said light, it is mentioned light inextensible string. Light inextensible string means what? The mass of that is not taken into consideration. Inextensible means when you apply force, it's not going to extend. The string is not going to expand or extend. So that is said to be inextensible string. Now take it as one mass, because it is inextensible when there is a tension and the spring is taut, stiff. At that time, we can say the whole thing as 30 kg, and this is 600 newtons. And now what is that? With 300 newtons is acting downwards and normal reaction is acting upwards. So N is equal to what? N is equal to 300 newtons, normal reaction. Okay. And we have 600, F is equal to what? MA. Implies 600 equal to 300 into A. So we get how much? A equal to 600 by 300, which is equal to 2 meters per second square. 2 meters per second. This is the acceleration. In these type of questions, they ask what is acceleration and what is the tension. So we calculated what is the acceleration now. We will calculate the tension. How will we calculate the tension now? So we will take one body at one time, this body at one time. Okay. Now, so when you take that this 10 kg mass, example, this is 10 kg mass, 10 kg mass. And now what happens? 100 Newton is acting downwards. Normal reaction is acting upwards. 600 Newton is forward. Acceleration is A. And this is the tension T. How will we calculate now? So for vertical forces, N equal to 100 Newtons, normal reaction. Horizontal forces, this 600 and acceleration is the same direction. So 600 minus T equal to MA, 10 into A. So implies 600 minus T equal to 10 into A. A is how much? A is 2. Implies 600 minus T is equal to 20. Implies T is equal to 600 minus 20. Implies T is equal to 580 Newtons. Okay. Is it 580? Okay, yeah. 20, 600, 20 into A, 2. So it comes this way, T is equal to 580 Newtons. So that is the tension in the string. If you want to apply the same here, 20 for 20 also. See, look here. Suppose if it is 20 kg, this is 20 kg, and this is the tension in the string, acceleration is here. So there is no backward force. So T equal to how much? The backward force, T is equal to right? 600 minus 2. Yeah, 600 is applied force. So this is not required. Only we can do with one. That is enough.
So why aren't we finding the tension when there's this combined mass? For 300 kg, 330 kg, why aren't we finding the tension?
We can still find out with that also. We will draw a free body diagram for this. 20 into, see, 1 second, 600 minus T is equal to Mn. 10, then.
Can you explain the F equal to ma, how you got the 2 meter?
This one, this one.
Yes,
Yes,
sir.
yeah. This is F is equal to ma. So we have taken 20 plus 30 at one time. If the string is taut, if the string is taut stiff at that time, this 20 plus 10 will become 30. That means the whole thing can be taken as one mass. Then
Yes.
30, this is weight is acting downwards, normal reaction is acting upwards, and this is 600 newtons. This is applied force. This is the acceleration. So normal reaction is equal to 300 newtons. If is equal to m, it is 600, which is equal to 3. That is I think I made a mistake there. MA, right? I have to take
Yes.
30, not 300. Here also I have to take 30. So this will become 20, right? So it is 20. So acceleration is 20. So I'll make it 20 here. So here it is 200. This is also 200. So how much it will be now? 400, right? Is it not? Here I made a small mistake. Okay, that is
Yes.
acceleration. Sorry, mass is 30, not 300. So 300 is a weight. Next one. Suppose if I want to go with the 20 kg mass, we can still try 20 kg mass. So this is the tension and this is the acceleration. See, T is equal to ma. That means what? T is equal to 20 into A. A is again 20. That will become how much? 400 newtons. Is it clear? E is equal to 400 newtons. Clear with
So
you?
why are you finding this separately? We can find it for the 30 kg thing, right? Why are we doing this for
No,
10?
means there is a tension here in the spring, right?
Yes, sir.
He's asking what is the tension in the spring now. When you do
Okay.
it, when you resolve the free body diagram in a two pieces, then only two parts, then only you'll be able to do it. Got it?
Yes.
Ah.
Yes, sir.
Okay, please note down this, then we'll go to the next question. These are all free body. Now, so there are two masses here. That is what 2 kg and 8 kg and 8 kg and 12 kg are connected to two ends of a light inextensible string that goes on a frictionless pulley. Find the acceleration of the mass and the tension. So 5.16. So in this question, it says this is the pulley and this is the mass, and this passes over the pulley, and there is one more mass. The mass is 12 kg and 1 kg, 8 kg. Let it be 8 kg here, let it be 10 kg. So that there is a tension here, tension here, tension here. So weight W equal to mg. So 8 into 10. And the acceleration is acting downwards. Here this is the acceleration. This is equal to 100 newtons. And this is the normal reaction. And so, so we'll take one body at one time. So we'll take this vertical one. So let it be A, let it be B. So for A, the vertical is how much? T is a tension. So we'll take 80 minus T is equal to ma. 8 into A. Why are we doing this one? Because the acceleration is acting in the direction of 88 Newton. That is 80 newtons. So that is the reason. Now 80 minus T is equal to 8A. Now, so that will become 80 minus T is equal to 8A. Right, 8, the direct here 8 into 8. Now coming to B, the vertical force and horizontal force. Vertical is how much? N is equal to 100. And horizontal is how much? Horizontal force equal to T. This is T, tension. So T minus backward force is not there. So there is no, did he say frictional force? There is no frictional force I think. Yeah, connected to when the acceleration mass of the train, when the masses are released. So T equal to how much ma? T is equal to 10 into A, 10 into acceleration. Okay. So, and the N is equal to, yeah. Okay. Now, T is equal to 10. Yeah, see once again, the vertical force here, 80 minus T is equal to 8A, that is perfect. And second here, normal reaction is equal to 100 newtons, okay. T is equal to MA, T is equal to 10A. So, we will substitute here.
What B? How is N 100?
N equal
You
to
wrote B.
downward force equal to upward force, vertical force. This force will be equal to this force, right?
Yes, sir. What is the A and B? I didn't
A
get it.
is this body and B is this body. Okay.
Okay.
Now, T is equal to 10A. And he gave here how much it is. There is no frictional force. If there is a frictional force, we write like this, F, small f here. But there is no frictional force. So T is equal to MA, 10A. So can we substitute this back into the equation here? Substitute 2 in 1. What do we get now? So 80 minus 10A equal to 80. So 80 plus 8 equal to 18A. A equal to 80 by 18. So that is the acceleration. Now substitute this T. T is equal to 10A. T is equal to 10 into 80 by 18. We'll get the answer for tension. Is it clear? So this comes with the friction also, but I will do that numerical also for you. Now going to question number. So what is the impulse imparted to each ball due to each other? So two billiard balls, each of mass 5.18. 5.18. In this question, he says two billiard balls, each of mass 0.05 kg. M1 equal to M2 equal to 0.05 kg. That is given to us. Now having a moving with speed 6 meters per second collide and rebound opposite direction with the same speed. What is the impulse imparted? So these two balls, billiard balls, they come towards each other like this. This is also M. This is also M. This is also U. This is also U. Both hit each other, and after hitting, they get imparted like this. This is M. This is M. Okay, they get imparted with the same speed, U and U here. Okay, so what will happen? So what is the change in momentum? So what is the change in momentum now? MV minus MU, right? Delta P is equal to MV minus MU. Impulse imparted into each ball due to each other. So it goes, hits each other. So then what will happen? So if this is positive, this is negative. So this will become minus MU, minus 2 MU. So that will be equal to minus 2 into 0.05 into U. U is how much? Did you mention that? Yeah. Within 6 meters per second. 6. So U is equal to 6 meters per second. Understood? So just multiply it, get the answer. Is it clear, girls?
So the last part.
See here, minus MV minus MU. Why? Going towards U is positive here, but here it will be negative. Why negative? Because it is moving in the opposite direction. So minus MV minus MU. So that will minus MU minus MU. That will become minus 2 MU. Okay? Minus 2 MU. So that is minus 2 into 0.05 into U. Clear? So that is the answer. Next question is 5.19.
So here change in momentum is a negative value.
Yeah, if you are see, it is having a direction. Momentum is a direction. If you are speaking about only magnitude, just write the value.
Yes.
Got it?
Yes.
Now next question 5.19. A shell of mass 0.020 kg fired by a gun of mass 100 kg. If the muzzle speed of the shell is 80, what is the recoil speed of the gun? This we have done in the exam. Third, that is conservation of momentum concept. We discussed this. Okay. So now here 5.19. See, there is a gun and bullet. So in this one, the bullet is here. So what will happen now? So the bullet comes out. So this is the M, this is capital M. This is M plus small m plus capital M here. So this is the recoil velocity V, and this is small v. So 0, sum of the momentum before collision, capital M plus small m into U equal to small m into V plus capital M into capital V. 0 equal to mv plus capital MV. So capital MV is equal to minus MV. So we have recoil velocity V is equal to minus MV by M. So substitute the values. V is equal to minus M 0.020 kg into velocity is how much? 80 by 100. 80 divided by 100. 0 and 0 will go away. 2 4s, 2 5s. So V equal to how much? Minus 2 by 100 into 5 into 4. 4 1s, 4 25s. So that will become minus 2 by 50, minus 1 by 25. So just write the values in meter per second. Is it clear, girls? Using the conservation of momentum concept. We are using conservation of momentum concept. Next question. A batsman. Are you done with this, girls?
No, sir.
Next question. Here, a batsman deflects a ball by an angle 45 degrees without changing its initial speed, which is 54 kilometers per hour. What is the impulse imparted to the ball? 5.20. So here, this is 45 degrees. This is also 45 degrees. This is U. This is also U. Now, the mass of the ball is how much? Mass of the ball is 0.15 and 54. 0.15 kg and 54. U is equal to 54 kilometer per hour, which is equal to 54 into 5 by 18 to convert into meter per second. 3 is U is equal to 15 meters per second. This is the speed of the ball. Now, we have two components. See here, we did this before also. Now, there are two components. What are the two components? This is 45. This is U. This is U cos U sin theta. Sorry, U sin theta, and this is U cos theta. Look at the direction. Similarly, now, suppose this is the reflection. That is ball of the reflection. That is equal to 45 degrees. This is U cos theta. This is U sin theta. U cos theta and U sin theta. So what is the formula now? Now x-axis. For x-axis, this is U cos theta and this is also U cos theta in the opposite direction. Okay. So it will become what? Now, Pi equal to initial momentum m into U cos theta. Pf equal to minus m into U cos theta. So what is change in momentum? Pf minus Pi equal to minus m into u cos theta minus m into u cos theta. So that will become minus 2mu cos theta. Minus 2mu cos theta. This is the value. Clear? Minus 2mu cos theta.
So then PF should be positive mu cos theta, right?
See, initially, if you are taking, this is along positive x-axis, negative x-axis. So that is why we took this positive, this as negative. Now, change in momentum is minus PF minus PI. PF minus PI, minus of minus, sorry, what it will be now? Yeah, it is correct one. Minus, so it will become minus 2mu cos theta. Clear?
Yes, sir.
Now, coming to y-axis. In y-axis, according to y-axis, what will happen now? So this is Pi is equal to what? M into u sin theta. Okay. And PF equal to also, this is also coming down. That is negative, right? This is also negative. This is also negative. M into u sin theta. So what it will be now? PF minus PI equal to what? Minus M into u sin theta. Minus of minus will become plus M into u sin theta. So the answer is how much? 0. Answer is 0. Clear? Clear? Clear, girls? So 5.21. A stone of mass m equal to 0.25 kg tied to the end of a string is railed around in a circle of radius r is equal to 1.5 meters. Speed v is equal to how much? Rotation omega equal to 40 revolutions per minute. So in a horizontal plane, what is the tension in the string? And what is the maximum speed with which the stone can be reeled around? With the maximum withstanding tension, it can withstand is T is equal to 200 Newton.